Hi everybody and welcome to your maths lesson for today. Today we're going to start by thinking about common multiples. What is a multiple? And I'll give you a clue. It sounds a little bit like multiplication. Pause the video and have a think. Multiples are any number in a specific times table. For example, a multiple of 4 would be any number in the 4 times table. So it could be 4, 8, 12, 16, 20, because they're all in that times table. Can you think of another number that is a multiple of 4? We could have, you could have 28, we could have 40. All in the 4 times table, and we can divide them all by 4 as well. A multiple of 2. Can you think of a multiple of 2? Any number you can divide by 2 or in the 2 times table. We could have 18, we could have 22, we can have 48. Today, though, we're going to be thinking about common multiples. If we say we have something in common, what does that mean? Pause the video, have a think. If we have something in common, it might be something we have that's the same. It could be something we like. It could be something about our appearance that we have in common. So common multiples are numbers which can be in several times tables. So you'll see I have two rings here. This picture is called a Venn diagram. We don't just use it for times tables, we could use it for other things as well. So we have 2 rings. This part of the ring is going to be the space where we put all the multiples of 2. This part of the ring here is going to be the space where we put all the multiples of 4. But you can see we have this bit in the middle, a shared bit. We've got part of the 4 ring and part of the 2 ring. What do you think we're going to put in here? Here are multiples of 2, here are multiples of 4. When they overlap and they're shared? That's right. In here, we're going to put the numbers that can be both in the 2 and the 4 times table. They're common multiples. You might be able to think of some already. However, to help us with that, I'm going to use my number square. You might have a number square at home, or maybe you might want to look at one on a computer, or if you're in school, you might have them. If you'd like to, use them to help you draw around the multiples of 2 and 4. We're going to start with the 2s. Let's count in 2s, and as I count, I'm going to draw a ring around them. The first one will be 2, then 4, then 6, keep saying them with me, 8, 10, 12, 14, 16, 18, 20, you've got it, 22, keep going, 24, 26, 28, 30 then, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, we made it. What is special about the counting in 2s pattern? Can you have a look? 2, 4, 6, 8. What's special about them? I'll give you a clue. If I have 2, I can do this. If I have 4, I can do this. If I have 6, I can do this. If I have 8, I can do this. I can put them all into pairs. What do we call those numbers that we can put into pairs that have nothing left over? That's right, they're all even. And you can see even 10, I can put into a pair. After that row, you can see that 12 is just 10, and I know that's even, and 2, and I know that's even, so it must be even. 10 and 4 both even, so 14's even. Do you see the pattern? So you can look at the last digit, because we always know that 10s are even. We just look at the last digit, and we can determine if it's odd or even. All of these numbers end in 2, 4, 6, 8. Let's now count in 4s to see if there's a pattern and see if there are any multiples in common. Off we go. Ready? 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. So multiples of 2 are in circles, multiples of 4 are underlined. Can you see anything in common which is the same? Which ones are the same? That's right, the ones with the ring around and the line underneath are the numbers which are in the 2 times table and the numbers which are in the 4 times table. So any of these are multiples of 2 and 4. Let's use this to help us with our Venn diagram. So, which numbers can go in the 2s? Remember, if they're in the 2 ring, they cannot be in the 4s or the shared bit. So ones that are only in the 2 times table, so that we're looking for the ones only with rings around. So I could put 2 in there. I could put 6 in there. I could put 10 in there. Could I put 16 in there? Yes or no? Why not? It is in the 2s, but what have I got underneath? A line, which means it's also in the 4s. So I could put 2, 6, 10. Can you choose another one that could go in there? Sorry, I've got hair on there. What other ones could I put just in 2s? You're looking for the ones with the rings. Yep, I could put 34. I could put 14, couldn't I? Let's see, 34. 14, there are lots you could put in there. Okay, are there any I could just put in the 4s? Remember, the 4s times tables, or the multiples of 4, are the ones underlined. Are there any numbers which only have a line underneath? No, all the ones that have a line underneath also have a circle around, which means every number in the 4 times table is also in the 2s. But not every number in the 2 times table is in the 4s. So I can't put anything in there. But I can put lots in here. Which ones would go in here? Yep, any ones with a circle and a line underneath, because it means they're in the 2s and the 4s. So I could put 4 in there. I could put 8 in there. I could put 12. I could put 28. So many. Have you got the idea? I'm going to now ask you to complete one of your own. So this one says common multiples, and we're doing 3 times table and 4 times table. Are any of them going to be the same? What could you do to help you? Again, you could create 100 square like me. You could use maybe circles around the 3 times table and lines underneath the 4 times table. That will help you get the pattern first of all, and then you can sort them into your Venn diagram. Pause and have a go at that now for 5 or 10 minutes. Unpause and we'll go through some of them together. Ready? Okay, as this one is filled out on mine, but I can use it for my 4 times table, I guess. I'm going to write my 3 times table along the bottom. So I've got 3, 6, 9, 12. Help me after that. 15, 18, 21, 24, 27, 30 then, 33, count on 3 more, 36 then, 37, 38, 39, then count on 3 more, after 39, 40, 41, 42. So do any of those, so we know all of those can go in here, but some of them might be in the 4 times table. If they're in the 4 times table, they could go in the shared bit. So we're going to look for the shared bit first of all. Let's see if any of these numbers are in the 4. Is there a 4? No, there's not a 4. Is there an 8? Because that's the next one in my 4 times table. No. But then I know there's a 12. I've got 12 here. So 4, 8, 12, 16. Have I got a 16? No. After 16, 20. No, I haven't got a 20. 24. Yes, I've got 24. After that in my 4 times table would be 4, 8, 12, 16, 20, 24. 28, no. 32, that's not there. 36. So those 3 can go in here because they're in both times tables, 24, 12 and 36. That means any ones that are not circled can go in here. So 3, 6, 9, 18, 21 and so on. You might have more. In my 4 times table, do you remember that underlined on here? I've got 4, I've got 8, 12, no, 12's in both, so I can put 12 in here. Oh, sorry, no, I can put 12's in both, sorry, so I can put it in here. That's already in there. 16, I can put 16 in there, yep. 20, 24, no, 24's in there, so it's in common. 28, no, it's not in my 3s. After 28, 32. It's not in common, it's not in my 3s, so it can go in there. Do you see the idea? So these are just in my 4s, these are just in my 3s, these are in both. How did you get on with that? Well done. Today, we are going to be continuing our learning on multiplication. Oh, it's got a little bit ripped out, I'm sorry. It says to multiply, so to times, a 2-digit number by a 1-digit number, which we're really good at now. We're going to be using our exchanging from yesterday. Can you remember what our exchanging was? That's right, we were exchanging, and you can hear me rustling around in my bag. We were exchanging our ones for tens. When does that happen? Remind yourself, pause the video. When do we exchange ones for tens? That's right, when we have too many ones, it gets changed for a 10. How many ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when we get 10 ones, it changes to 110. So 10, 11, 12, 13, we'd have to change for a 10. If we're changing 11, for example, we'd change it for a 10, and then we'd keep the 1. If we're changing 12, we'd change it for 110, and then keep 2 ones. There's an extra thing we're doing today as well. It says the column method, which we're also familiar with. So we're going to combine everything we've been doing so far. 2-digit times 1-digit, using exchange, and presenting it as the column method. I know you're going to do super well as you're already good at these 3 things. We just need to put them together. The first thing we're going to do is revise a little bit from yesterday, which was exchanging. So I've got my 2-digit, my 10s and 1s, times a 1-digit. Let's read it together. Ready? 27 times 3. How did we work that out with our place value grid using hundreds, tens and ones? Can you remember? If you're confident, draw out your place value grid and draw in the 27 3 times. If you'd like some help, stay on the video with me. Ready? So I know I've got 3 rows. So I'm going to put 3 rows in here. And at the bottom, I've got a row where I'm going to add up my columns. Let's draw 27. Ready? 10, 20, switch. 21, 22, 23, 24, 25, 26, 27. That's one group of 27. I need 3 groups. 10, 20, count with me, switch. 21, 22, 23, 24, 25, 26, 27. 3 groups for 27. 10, 20, switch. 21, 22, 23, 24, 25, 26, 27. So I've drawn out 27 times 3. How am I going to get my answer? That's right, I need to count up my ones. Remember, we always start with the smallest ones as they're very impatient. Can you see that there's a problem though? It looks like I have too many ones. So I have 1, 2, 3, 4, 5, 6, 7 in here, 7 in here, and 7 in here. What does that make all together? Do I know 3 times 7? Some of you might know your 7 times tables. If so, you can count in 7s. Remember, you can just switch them round. So I can do 7 times 3 instead. Let's count. 3, 6, 9, 12, 15, 18, 21. Are the ones going to be happy with that? What do you think? What should we do? They're not going to be very happy because I can see that there's a 10 in here, more than 1 10. There are 2 10s. What are the ones going to say to these 10s? They're going to say, you're too big, get out. Can you pretend to kick them with me? So they need to kick some of them out. Which ones do they need to kick out? Because I've got 2 10s. That's right, that means I need to circle 2 lots of 10s. So I'm going to use Salwa's method. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 1 10. Remember to double check as it's easy to miss some out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Double check again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to rub that out now. They get kicked out and they go into the 10s. And my 1 stays here. Don't forget this little 1. Now I can count out my 1s. I've only got 1 left. So I'm going to move this a bit higher because they're going to get in the way of my adding. So now I've got 10, 20, 30, 40, 50, 60, 70, 80. Or I could have counted in 20s there. 20, 40, 60, 80. 80 add 1 is 81. So that's how we do it using our Dean's drawings. And we regroup, so we exchange the 1s, the 10 ones, for 10s. Remember, sometimes we might have to exchange more than 10 ones. Here we have to exchange 20 ones for 2 10s. This one for this one, this 10 for this one. Let's see how it looks as the column method. I'm going to leave them side by side so you can see. So my number sentence is 27 times 3. If you're doing this on squared paper, make sure there's 1 digit per square. The 10s have their own space. The 1s have their own space. Okay, then underneath, we're timesing by 3, so I put my 3 under here. And then I draw my same as sign. Some of you forgot that last time. Still really important to show, as that's where your answer goes, just like here. It even looks like it, look. Where's my time symbol going to go? Because the person who's looking at this needs to know if you're trying to do a times, an add, a take away. So we put this symbol and we put it here. It doesn't go here because sometimes we'll have a number here. Right, are we ready? What's the first thing we do? Do you remember? We go to the 1s first, just like here. I'm going to go down. So we do 7 times 3. Ready? 7 fingers up. If you know this already off by heart and you can just do it, that's amazing. If you need to use your fingers, that's okay too. Ready? 7 groups. 3, 6, 9, 12, 15, 18, 21. So my 1 can stay in here because it's a 1s, but my 2 10s go underneath. Just like they've been kicked out from here and they go underneath here. The 20 from 21 is going to be kicked out and go here. It's in line with the 10s now. Can you see? Which way do we go next to times our... Yep. So we're going to times 2 10s by our 3 1s here. So we go diagonal. Ready? 2 10s times 3. What's it going to be? That's right, it's going to be 6 10s. 2 groups of 3, ready? 3, 6. But remember, it's not 6 1s because we're timesing 2 10s, we're timesing 20. So that 6 will turn into 6 10s, which is 10, 20, 30, 40, 50, 60. So we've got 6 10s, but here we've got 2 10s. And even though they're new, they say, don't forget me, I'm a 10 too. So we do 6 10s. Add 2 10s is 6, 7, 8 10s. 81. The trick is to not forget those ones which have just been changed. I know they're new, like if you're new to a class, but you like to be included too. So we do 2 groups of 3, 6, and we know it has to be 10s, that's 6 10s. Add 2 10s is 8 10s. Got it? Looks a bit like this, look. It is 7 times 3. We kicked out the 2 10s underneath, which is the same as here, but left the 1 in here. Then we did the 10s times the 3 there. We added the 10s that had been exchanged to get our answer 80. Looks the same. Shall we have another go? This time I'd like you to get a whiteboard or a piece of paper and do it along with me. Whilst I'm rubbing out, let's see what our next number sentence is going to be. It's going to be 45 times 2. Are you ready? 45 times 2. Let's draw out our place value grid. Hundreds, tens and ones. This time I need 2 rows, sometimes in 45 by 2. And the 1 at the bottom to add up. What do I do first? Can you have a go? You're going to draw 45 how many times? Twice. Where's it going to go? Here and here. Do that first. Pause the video, unpause when you're ready to go through it. Off we go. 10, 20, 30, 40, switch. 41, 42, 43, 44, 45. That's one group of 45. I need 2. Underneath, 10, 20, 30, 40, switch. 41, 42, 43, 44, 45. So I've drawn it out. How do I get my answer? That's right, I need to add my 1s first. How many have I got in each one? I've got 5 in here and 5 in here. 5 add 5 makes 10. Oh dear. Can I do that in here? Thumbs up or down? What are the ones going to do? Get ready to kick them out? Get out! You're too big. So we have to circle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of them are being kicked out. So we've got 10 ones and they go into here. What do I write in here now? Do I just leave it blank? No, I need to write a 0 to be a placeholder. You'll see why in a minute. Let's count my 10s. 10, 20, 30, 40, 50, 60, 70, 80, 90. 90 add 0 is 90. Great. Perfect. Let's now do that as the column method. Ready? Okay, on the same piece of paper or same whiteboard. Okay. So 45 times 2. 4 in 1 square, 5 in 1 square. Remember, this is 4 tens, 5 ones. Underneath, my 2 ones. The ones stayed together, so the 2 must go underneath the 5. We're used to doing this with our add and take away column method. The same as sign goes underneath, and my times sign goes over here. What's the first thing I do? Where do I go first? Can you pause the video and have a go at solving this yourself now? And then unpause to correct. Ready? I do this one first. 5 ones times 2 ones. 5 fingers up, counting 2s. 2, 4, 6, 8, 10. Okay, for the number 10, my 0 stays here, but I kick the 1 10 into here. So all of my ones from this have turned into a 10. I must put the 0 here. Remember I said, see why in a minute, it has to be a placeholder. Then I do 4 tens times 2. Put 4 fingers up, count in 2s. 2, 4, 6, 8. So I put 8, but remember they're 8 tens. Oh, wait a minute, what do I need to add? This one says I know I'm new, don't forget me. So we've got 8 tens from here. So we go diagonal, remember. 8 tens, add 1 10 is 9. Do you now see why I've had to put my 0 as a placeholder? If I didn't have that, it would look like my answer isn't just 9. I know it's in the tens column, but if you just see that 9, you think, oh, my answer's 9. So the 0 must be there to show it's 9 tens and 0 ones. It's a placeholder. Okay, we're going to do one more. This time, though, we're not going to do the place value grid. We're just going to do the column. We're going to do, let's put this to one side, 39 times 2. Can you have a go at setting that out as a column method and solving it? Unpause once you're ready. So 39, 3 in 1 square, 9 in the other, 2 underneath, because we're timesing by 2 ones, so it needs to go in line with the 9 ones. Same as sign, multiplication sign. What's the first thing we do? That's right, we do 9 times 2. Or 2 times 9, whichever way you want. 9 fingers up, ready? 2, 4, 6, 8, 10, 12, 14, 16, 18. In 18, I have 8 ones. They can stay in there, but they say, get out to the 10. Must go underneath, in line with the 10s here. Then I go diagonal. I do 3 10s, because remember that's 30, so 3 10s times 2. 3 fingers up, counting 2s, 2, 4, 6. That makes 6 10s. Add 1 10, 6 add 1 is 7 10s. So my answer is 78. Did you get that? Well done if you did. I would now like you to go into your portfolio where you have got a sheet with lots of different puzzles to solve. Some of them ask you to solve the multiplication like this. Some of them look like this. And some of them use our place value counters. Do you remember our place value counters? These ones. We also have them in 10s and 1s. So have a go at that, and please upload once you're done so I can see how you've got on. Well done for tuning in today, and I'll see you tomorrow. Bye for now. Enjoy the snow.